Hello. Let me just start by doing a typical kind of promotion type thing, just to make sure that everyone knows I am streaming so they can come and join us. Yes, let us begin doing this. So, first I must find a link to the stream. I must place it in the Discord. We go to the Discord, we place it in the Discord, we say, here, streaming network sync into the function for player movement, into, streaming network sync between worlds, player movement, ship, and that. See. Excellent. Okay. And I probably should put this into my announcement of what we're actually streaming. So, what are we streaming? Blast. Great. That looks about right. Update information. Welcome, Togglebit. Nice to see you. Hi. I should like wave one arm at an angle. Hi. Anyway. We'll just make one on the chat. Excellent. Search for a category. Apparently I'm supposed to use science and technology as my category. Search tags, game development, software development. Yes, that'll do. And then I also need to make the effort to make a Reddit post about this. Reddit. I'll end up with 1,000 people watching me get tired. What's Tom been up to today? Yes, let's not dwell over much on Tom's recent choice of links. Okay. Whoops. So, we need to go to Watch People Code, because that is what one does. Where are we? There we are, Watch People Code. We're not going to watch people code. Well, I'm not going to watch people code. Create post. Link. And it's Godot plus Rust. Tonight, my friends, we're going to take over the world. Tonight, working on network sync. Yes, in Rust. URL would be a Singularity post. Almost there, my friends. Okay. The create a dashboard. It shows me all the nice things, like myself and how many people are watching and that sort of thing. I just put this tuck away over here so that every now and again when I get distracted by sitting around and slacking, I look up that number of viewers and I go, and then I start talking again. That's typically what happens. Yes. Okay. That looks good. Today I'm wearing the logo for my local gym. It's a very shiny t-shirt. It looks pretty cool on camera actually. Maybe shiny t-shirts are the win for this. What is next? Okay, so the last thing I was doing was just making a few changes to this example I made last night. I might just quickly check to see if I managed to successfully make those changes. I got a lovely pull request review. See if I can find the relevant tab again on my screen. All these screens popping up. Where are we? Might have to open it again. I think I closed it. GitHub. In here, we had a pull request, and in the pull request, I made a specs integration example. This is what I was mentioning on Twitter last night. Oh yes, Twitter. Doing that streaming. Let's just write this on Twitter. Doing that streaming. But so, I'll just probably need to close a few of these things. Countdown to the next path of exile. Doing that streaming bizzo again tonight. Rust, networking, sync stuff. Tweet. Great. Hi, Weird Constructor. Nice to see you. Thank you for joining us. It's always great to have my regulars along, the crew. I'm glad you're here. So in this example, I got some lovely comments from Toasteater, and I've just gone through and made all these changes that he suggested. So let me just open that example up. I'm just going to very quickly push those changes that he suggested. So I've taken the helper, I've removed all this helper stuff. In lib, I removed some kind of soft failures and turned them into expects so that it'll have a nice explosion instead, which is probably actually clearer. In sync, I improved some of these comments. He pointed out that if you have values inside an enum, those are called variants. So I changed the comment. I forgot, actually. I think that had been mentioned in the past. I knew that sometime. I've heard of that word a lot. I just never really clicked that that's what that word meant. Yeah, blah, 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 blah. Added some more doc strings, entity create. The helper I told you I deleted, this is one of the functions from it. I popped it in here instead. And in delete, here's another one of the functions from helper. I popped it in here. And Godot sync state, one more function from helper has been dropped in there. And then in basis, I took out these things which were commented and made them actual code, and they're not very well tested. Hopefully no one runs into a problem. So those are all the things I've done to address the pull request comments. Let's just quickly run through it should take about 10 minutes to close this off, and then that example is updated tonight, and Togglebit can do another round, get the pull request moving forward. This is an example I made last night if you're interested in using specs and Godot together, specs being the ECS that I use. Trying to share back a bit of code, because I don't feel like it's safe for me to share all my source code and have a commercial product, but I can share parts, and the root search I managed to do as examples I think is a really nice thing to split off and share, so that's what I'm trying to do in general. Creative learning specs. It was this really crazy name. No, I didn't call it that. Okay. That's the one. Go.rust specs example. Why can't I remember that? Let's run a build, and then we'll run Godot, and we'll run these. Oh. Well, now I see why I commented that code out. Let's just comment it back out again. Okay. So it's transform. This one will do. Let me just make this window as big as the area that you guys can see, rather than as big as the area I can see, or else I will start making terrible mistakes about what I show on screen. Okay, transform. Transform methods. Yes, basis. And here's this function here that I've ported, but haven't finished ported, and so has grievous problems with it, I believe. Oh no, it's these ones that have a problem. Okay, so all these v0s are actually v.x. Let's do that. So v0 is actually v.x. This is because I ported this from C++, you see. And then v1 is v.y. Replace. And then v2 is v.z. Replace. And here. Replace. Where are you? Replace you. Great. Okay, that should probably compile now. Element new. We don't call the element new in basis. We probably call it something else. Ugh. Yeah. I can see why I gave up on this before. I really just can't be bothered. It's not necessary. So this from Euler. I'm just going to delete this for now. It's still in my commit history if I ever want to get it back. It's not necessary for what I'm trying to do. Rather than using this, I'll just use this other compiler window I'm using. I think I've lost my Twitch window where I can gaze upon my viewers and be afraid. Where did I put this? Be afeared. No. This is Raphael's latest YouTube video. I was reviewing that as important homework. This is the author of a plasticine arcade game. What did he call this game? Planet Cleaners. If you want to watch some videos, Raphael Hort. If you want to find more out about this, you can always join my Discord, and he's on there, and you can talk to him about it. I don't need any of that. I just was looking for the Twitter. I'm a bit disorganized, you see. I was kind of organizing, and then I was like, oh, it's 9 o'clock. I better just start streaming. Part of the disorganization was I tried to boil my tea in a kettle, and the little switch that turns off, called an RCD, detected something wrong and turned off. And did that 4 times before I gave up. So I plugged into the other wall socket to test it again. And while I listened to the kettle going, the computer turned off from the breaker. Which is probably for the best, because fires are a bad thing. So it all worked out fine. The kettle's in the bin now. But it did slow me down slightly. And on that note, I'm really glad that we have modern houses with modern wiring and everything is so wonderfully safe. I'm trying to find Twitch. I'm typing in Twitter for some reason, which doesn't generally get you to Twitch. Let's bring out my console again so I can gaze upon my viewers and be afraid. Oh, there's 8 of you now. That's lovely. Thank you for sharing. No, there's 7 on this other console. I wonder if I should be worried about that. Anyway, downward trends are good. There's pressure. Let's run this. So there's more complaints. Try and load scene. So I moved this code, as I said, out of helper. So not surprisingly, some stuff that's required. And I love how Rust tells you what you need to do is to include standard hash. Yum. Hash is delicious. Debug is not a trait. So this one is we need to use standard format debug. Ta-da! Mismatched types. I just guessed the type. I knew that the error would tell me what the type should be. So this constant needs to be of this type. Put that there. Hi Wildly, nice to see you. I have no idea what the cool symbols, by the way, next to your names over there mean. I'm sure they mean something really awesome. Oh yes, that's right. I made Weird Constructor a moderator in Twitch as well, so don't you guys piss him off or else your messages will vanish. He's also an admin in our Discord. Okay. So, in my command prompt now, I'm going to use cargo. Oh, first I think it'll complain if I don't. Let's just take this stuff and stage it and make a temporary commit. Apply cargo changes. Apply PR suggestions from toast heater. Although that's kind of redundant because I'm going to rebase everything in a minute. So cargo format. This will make everything look pretty. So if I go into cargo, you'll see these things here have been fixed. It's just made some simple changes where I, as a mere human, have made trivial errors. And then the other one is cargo fix. And it's going to complain that it's not committed, but I can just go allow staged like this, and I can do it without committing again. It's going to do some thinking, and it's going to remove a bunch of imports I don't need. Don't worry, Weird Constructor, there's no need to take your job seriously at this point. Like I said before, no one's done anything egregious, but later on when, you know, I'm streaming and for some miraculous reason there's 1,000 people scrolling past, this will get more interesting. The idea right now seems completely mental, but, you know, you do this for long enough, eventually people show up, it seems. Okay. So in helper it's removed some, Well, the helper file was supposed to be deleted, so it's not surprising it's deleted all the imports, but what it really shows me is I forgot to delete the entire file. Helper is now empty. So I'm going to delete helper, and then inside lib, in here I had a module, because that was one of the suggestions. It's like, well, this is a redundant file. In an example, you want to minimize the number of files. Oh yes, that's correct. So let's just try and build it one more time, now that I've made all those changes. So cargo fix and format. So you'll notice here, if you look at my tree, here's master, and here's all the changes I'm making. It's quite a few. It's not ideal, and this is why we're going to squash those soon. Great. So that built, we're going to go to Godot, which I have already. Here's one I cooked up earlier, and specs integration. Once it's loaded, I'll bring it across to you. Here we go. So this is a project ready to go. You can load this example, and when I add children here, it's creating them in specs, and then it's adding them to the scene. Later, for a later example, I might put one which uses physics and has them fall down to a ground plane or something, just to demonstrate how you can update something in specs. I haven't done that yet. So that proved that I didn't change anything. Nothing was broken. Commit. Everything's committed. Okay, so the next thing we're going to do, I'll just tag this real quick. Create a new tag here, and unsquashed. So by putting a tag on the commit, it means that no matter what I do with this branch, it won't get lost. It's just a convenience. Yes, toggle bit. I was planning to make a physics example separately. So we're going to rebase this entire branch on origin master here. So let's do that. Right click, rebase branch on that, and we're going to use interactively. Okay. So we're creating a new set of commits. So interactive committing means that it creates a little list like this. Can you see? And every commit gets turned into its own line in this list. And so what I can do is it runs these in order from top to bottom. And I'm going to squash all these other commits down. S is short for squash. On top of the first one, squash, squash, squash. And this will turn it all into one commit. When we save and exit this file, it starts working on it. Now it's squashed them all, and it said, what would you like to use as a comment? So we'll just get rid of whip, add a new specs integration example. And add the first helper functions for basis and transform. And then all my other stuff here, I'll just say includes PR suggestions from Toast Eater. Right. And the rest is just commented, it's going to be ignored. We'll save that. Okay. So we've got all the commits here that we used to have underneath this tag called unsquashed, because they still exist. Rebase has actually created a completely new commit, but it's backdated it to have the same timestamp as the very last commit here. Well, actually no, because it's squashed, it seems to have made a new timestamp for the current time. Anyway, this is what we're going to push. So one commit containing all the work. So this is often what I do. I commit a lot, and then if I don't like how many commits I have, you can squash them, and you don't have to squash all of them. You can say, I committed this thing, and then I fixed it a bit, and I fixed it a bit, and I fixed it a bit more, and then I added the next thing, and I fixed that a bit, and I fixed that a bit, and so you can squash those last two into this one, and so now it's perfect the first time, and then you can do the same thing with those three and squash them into the first one, and so you do it with two commits that look really beautiful, and that's what you can do with squashing. It makes you look like a pro. It's a good trick. So we're going to push this branch. Push, and we need to force push. I always use force with least, not force push if you can. The reason why is if somebody else has made a change to my branch and I didn't know about it, force with least will cause an error, whereas force push will ignore their stuff and throw it away every time. So we're going to push that. Now you see this green branch here is an old feature transform methods, and up here, actually that's the only one. So that's an old branch in the remote I don't want anymore. So I can use push multiple branches here and choose the one I don't want, which was Tom feature transform methods. Tom feature transform methods. This one here. So we're going to delete from the remote branch, like so. Push. It failed to push some stuff. Did it manage to delete that branch? Yes, that's all I really cared about anyway. So now that that's done, we shouldn't need this tag. We shouldn't need that tag in a second. We'll delete the branch. Force delete. Yes. Okay. And we can delete this branch. Delete master. Force delete. Yes. These are both local branches. Okay. So the only thing keeping all these commits on my tree is that tag I added at the start. So we're going to run Godot one last time. I need to import this again and check that I fix the project name, because it doesn't look right in that list. I'll just check it again in a minute. So let's just run this. Add, remove. That looks good. Great. Project. Quit to project list. Yes. From the project list, I'm going to remove, import. So importing is how you add something to the project list that already exists on your file system. So that's what we're doing. We're going to put it back. I want this path. So I have quick edit, an option in Windows called quick edit turned on, which means I can just mark like this. If you don't have quick edit turned on, you have to right click to mark things. It's pushing enter as copy. Browse. Examples. Specs integration. Project. Import and edit. Oops. I didn't mean to go straight into editing. I wanted to see it in the project list. Yes. Okay, so this name here, scene create example, is still wrong. Rename. So we want to call this specs integration example. Rename. And exit. Wonder what file it changed. Commit. I totally thought I'd done that by hand. Hopefully I didn't do that to a different file. Let's have a look at what files I did change here. Diff. Did I change the project file? Speaks in, well, I created the project file. I didn't change someone else's project file, so that's a good thing. And in project, scene create. Oh well, I thought I'd change that. Maybe Godot saved over it again or something. Anyway, in this case, we can use this option amend commit. This will recreate the commit that we originally squashed. So I've just changed that and made another one. So now there's two versions of this commit. One of them is on the server and one is local. So we're going to push the local one, and again we're going to force push this. So this whole force pushing thing would be a problem if someone else had checked out that code in the meantime and done something with it, but I know no one's going to do that, so it should be fine. Sorry, by the way, if you have already pulled out my code and forked it or something, since I tweeted about it and got, I think it was like 6 likes and 20 something likes, 25, and 5 retweets, which was pretty good for me. I'm really glad that what I'm working on is of such use. Delete. We'll delete this tag. Delete. And so all those commits have vanished. They're actually still around, but you have to do a search to find them now. And this is all in order. And yes. So Mr. Toast Eater, who I don't believe is on here, but I just tell him in here. I just updated my branch that you reviewed. earlier. Thanks. Excellent. I see I'm up to 9 victims. 11 viewers. 11 viewers. So now we can change subject. We're moving out of this Rust example, so let's close that project. If you're into specs in Godot, I suggest you check it out. Do I want to give you a URL? If you look for Godot Rust and look at the PRs, you'll find it. My name's Tom Lees, so it's pretty obvious which one's mine. Okay. If you really want to know where it is, just ask about it in chat and I'll tell you. Okay. What is the job today? Well, the job today, my friends, if I just go, I'm going to load up the relevant Star Factory repository. Do I even have, I think I've even made some unit tests around this. Yes. Yes. So, what we've got going on here, Singleton, is I've been, up till now, if you've been looking at my game, you've seen a client with 2 spaceships in it, and you might have seen them crash, right? So I'll just give you a quick GIF to remind you what that looks like. Pictures, GIF cap. So I make a bunch of GIFs of things as I go along, and here's a really cool one of 2 ships crashing that I'm totally hammering right now because it looks awesome. Hey, Carofel. Hey, it's awesome to see you on here. Thank you. I'm glad that you appreciate it, and I appreciate all your work so far. We all appreciate it. There's like a whole channel of people admiring the results of the things you've done so far. So thank you for your work. So those are 2 ships crashing. Now, if you looked at my Singleton code, I have this thing called build test starships, and down here, I actually create the ship. Where is it? Here. I create the ship, and it's worth noting that this code is called on both client and server. So both the client and server, both clients, call this add spaceship at the start, and that's why they both have the same ships in the same place. We want to change it so that when the client joins, the server tells them where the ships are. And so to that end, this build static sector function, if I have a look for this, where are we? So here's run server, and here it is being called, and here's run client, and in here we don't want to call it, right? But I think it was actually called also in our core. I had a feeling that I had somewhere else where it was called. When I was looking at that diff a second ago, I thought I saw myself commented out. Let's see. Yeah, see here. Oh, I was probably commenting out something else. Okay, so we essentially want to be able to remove this code here and have everything sync. But if I run that, and it might not compile, actually, because I'll be making changes. Let's see if it compiles. If I run that, you won't be able to see the spaceships. This is something I think I might have shown on stream before. Or I showed it in my imagination. Don't worry, we construct our game yet. We'll eventually update. We're all in the know. We know what's going on. Okay, that's interesting. So both ships are showing here, which is not what I expected to see. I can't make these crash in this version because all my input is being routed towards moving the little player, who you can't see moving, which is also interesting. Okay, anyway, it's probably a sync issue. To demonstrate what I'm trying to do, I think what you'll probably find is there's somewhere in here where the client, where's the client? Lib, core, bridge, Star World link, and inside of ready, this is where we actually set things up. Get or create world. So start client's probably the one we're using. Build static sector is being called. Yeah. So that build static sector, that was the one I need to comment out. Which one did I comment out? I'm confused. Something else. Okay, now I'm running something completely different. I just pushed Control F5. Probably running the wrong project. Run. So can we cancel that? Stop. Run. I usually from here compile SG Core, which is my Godot game, my Godot DLL. Yes, that still compiles. So if I run the game now, we shouldn't be able to see the ships. Yep, invisible ships. But what you can also see, if you wait just a moment, is it will still output the little ships here. So what's going on is the server has told the client about that there is a world, a production floor world, but it hasn't told the client that there are ships that link the world into a 3D position in space. And so without that link, we can't render them. So the thing I want to add is that specific thing. Hopefully you guys are with me on this. So you see the little world is being rendered, but it's like the spatial isn't being created. That puts the ship in space. And I've got a much more succinct unit test to show you. So if I go into SG simulation, so for those who are uninitiated, SG simulation up here is completely pure Rust. There is no Godot involved in SG simulation at all. The only SG core knows that Godot exists. So SG simulation doesn't contain the GD native library. It's just pure Rust in algebra, physics, that sort of thing. In here, and let me just look at the diff to remind myself what I've changed. So in here, inside of the space world, I've created a test called ship creation. Let's have a look at that. So the ship creation test creates a sector, and then it inside of it creates a world, which is like a production floor. It's like a little factory, and then it gets the space world, creates the space world, it's empty, and then we add a spaceship. This is all on the server essentially, and then we ask the server, please figure out what packets you'd send to a client. If you look inside relay to client, we pretend we have a client, WAV ID, test connection ID, and this creates some packets. So here is an example of the packets it creates. So if I'm in world creations actions OK, this other one I create a series of packets. So for your interest, if we create a world, we place a module, we submit another action here, and then we relay those to client. These are the network messages that get sent. Now I'm just going to read this chat for a second. Yeah. So there's a bit of drama with the Are We Game Yet, where people are making changes to the repository, but they haven't automated the process of putting those changes onto the website. So our lovely contributors, as mentioning in the chat box here, are not getting their contributions showing how awesome Rust is getting on the Are We Game Yet site, which is a great reference generally. So what I want you to see here is these are a series of network messages. We're not sending any messages to create a space world, so we need to create one of those. We'll make this vertical. So if we go back to space, we'll ask ourselves, well, what messages are getting sent? So here I output the messages that are being sent onto the console. So that could be useful to see. And we won't bother asserting on them just yet. And then we will run. Now, this is a point where I'm going to regret changing my default target. Eventually I'm going to regret changing my default target, because C-Line can't debug the target I ended up using for the Rust specs example. Rust up default If I look at this, it's running 64-bit PC Windows MSVC compiled, but C-Line can't debug that Rust target. I need to change it to show this one, 32-bit GNU, which is what we can actually reliably debug using C-Line, or a nightly version of the same. Nightly GNU, we're going to go with this one. Okay. So Rust up default, right click on this, done, and now we can go run. We're going to run test of SG simulation. So the test target is going to compile the tests, and it's going to make a little UI that shows us how lovely they are. Let's just move to the right. No? Oh, it's because I haven't got dock turned on. There we go. So hopefully if you wanted to read some of my network actions, you've done so. Yeah, that's right. I mean, Are We Game Yet is obviously a volunteer organization, so, you know, none of us are like angry or anything. We're just looking forward to when they have some time. And everyone's really busy with Christmas and so on. Okay, so this is my tests compiling. And so this is one of my mini tests. I'm up to 100 and something tests. So in this test, we create a space world. We put a spaceship in it. We find out what packets we want to send. It doesn't currently want to send any packets to tell the client there's a spaceship. That's what we want to fix. Let's have a look at what packets are going to be. So they should show up in the window once the compilation is done. And then we tell the client to process those packets. And if we look inside here, we should find there's a space world. And what's more, if we look in here, we should find there's multiple spaceships. At the moment, the test fails here because it tries to find all the spaceships on the client, and there are none. And this is like a unit test that demonstrates exactly the problem I have. So look at my tests down here. It says I've got 120 out of 120 tests. 120 tests are passing of 121. The one that's failing is this one. Let's have a look what messages get sent. The server tells us what tick we're up to. The server tells us to synchronize the ticks for a particular world. This functionality where it does the synchronization per world, which I think I still want that. Yeah. I was going to say that's probably redundant now, but now that I think about it, we still need it to be per world. So there's some fields in here about what tick is the factory up to, when's it going to tick next in milliseconds, CRCs of the world, and possibly different speeds for different factories. So if one factory gets seriously overloading the server, we can slow down a factory to like save the server from dying. Grid chunk update. This is data about the ship. So it's basically a block of data that says there is no ship at the moment. And so we need to add a fourth one here or something earlier that specifies that ship. And down here on the client you can see there's no ships. So when we create a list of all ships, we end up with an empty list. So we get... Now this expected and actual is run backwards because this editor expects me to put them around that way. Okay, so that test is currently failing. So with such a nice narrow test, we can now look into, we should be able to run this in a debugger. So I can click on this and go debug and put a breakpoint in this like so, and then run debug. And it's building again for some reason. That's right, I swapped the tests around to the opposite side. So I've got a little debug window with a call stack, and we can F10 step through things and look at variables and step in and step out and all those other really good things. I don't actually really want a debugging session, I just wanted to demonstrate I could have one. Oops, I didn't stop the debugging, I showed a window about it. I have issues with my monitors and DPI. Whenever a new window shows up, it has the little bug to do with, you know, stuff. Anyway. Nice one, Wii Constructor. Okay, so ship creation. I need something detecting that there are spaceships that aren't being synchronized to the remote client. We also need to track what stuff has been synchronized. And this is generally going to be a pretty general problem. I think I already added the component that I was planning to put in here. Where did I put this? Sector. That's all testing stuff. Maybe I'm just imagining things. I thought that I'd created a component to store this. So, here are these white windows that are burning my eyes. Ship link. What did I call this thing? I think I put it in the spaceship here. And I have a component called spaceship. Here's a spaceship. I always feel like saying spaceship from the Lego movie. Whenever I do that, 1980s spaceship, Lego man. Anyway, so we know where our spaceship is in X and Y, X and Z, and have a facing. But actually, strange enough, this isn't really what we want to synchronize. We want to synchronize the entire position as calculated by the physics. And we're going to be doing it on a fairly regular basis. And we're going to be doing that for most physics objects, handling a synchronized position. So I'm thinking we're going to need a system that can do snapshotting. That system is going to have to send essentially actions to the other worlds that are going to update their relevant things to the correct locations. Because in my world, the idea of an action is something you queue up to a certain tick and then you apply it. Yeah, so we'll use the actions approach for now. So I need a new system that knows how to serialize things like spaceships. So let's go into here in spaceship, and we're going to create a new system that knows how to do the serialization. Well, I have a trick for this now. So I go into spaceship, and in here I say mod space serialization, and it goes red, and then I use create module for it. Like so, and it creates a file. Do I add to Git? Yes, that's cool. So I've got this empty file, and my space serialization class. Let's think, what sort of things are we going to want to serialize? So, I like to copy an existing system, so I'll just grab this one, and I'll have a look at specs as a starting point. So we need specs, prelude, star. My nose always seems to get blocked on stream. I'm always too embarrassed to blow it. Maybe I just get wheezy from breathing too much. Okay, excuse me, medical problems. Too much talking. Okay. So we're going to create a system. We first need to struct. It's called space serialization, like so. Doesn't have any data in it. Implement a system for space serialization. So this is for creating snapshots of things that are in space. So I'm going to take the very naive and high data approach to start off with. A naive and high data approach is to every so often with ticks, we just grab all the data, we lump it all together, and we throw it across to every client. Down the track, we're going to get smarter. We're going to use snapshots and deltas. But to be honest, the number of things in space is really low right now. So this will actually get us a surprisingly long way. So what do we need access to? Well, I'm going to want access to things, to positions of things. So I've got a pos class for that. Pardon me. Something about streaming that just brings out all the worst behavior. We need a read storage for... let's do one for bipeds as well. So I need to be able to read biped, which is like the little person. We'll read that. What else do we want to be able to read? We want a read storage for a ship. So I put that in the ship component. So spaceship. I want to be able to read those. Import this. Import reading of spaceships. Cool. So I've got those three things. This is all spec stuff. If you guys haven't done much in specs, this is creating a system is how you modify data. So we've got a run method, and when this run method is called, it's going to get past these three things: spaceship, import. In order to do synchronization like this, we're going to need to have some sort of network ID number. I don't think I already created one. Logistic. I'm pretty sure there isn't any. Because in the logistic one, we could get a long way from the position. The position of an item in space was essentially an ID. And that was on a 2D grid, and so we could get away with that. Whereas here we need something to something to manage that problem. So inside spaceship, inside here, let's just create a component that's going to store an ID number we can use. So entities already have an ID number, but unless we share it between the server and the client, it's not reliable. It's going to be different between the two, probably. Yeah, I think guaranteeing it's the same is going to be just such a headache. So we'll create a component. We'll call it network entity. And network entity is going to have an ID number. So ID, and we'll make that EU32 for now. I'm going to stick with that. Yeah. So it's this, and there's network entity as a component, so we have to go impl component for network entity, and we need to specify something called storage, and it needs to be vec storage for a network entity. Let's have another look at impl component. So choose one, and that's what storage looks like. And so that's what I'm going to put here. But we don't want it to be a flagged storage. It's not necessary. No, it's not. And we don't need it to be dense. It's probably fine for it to be non-dense, which is cheaper because we're going to probably put this thing on everything. And yeah, it's a type. Apparently. Great. Okay. That seems happy. So we need a component for network entity. So we just made this new thing. Now our space serialization is going to write to those things. Write a network entity. Great. And the last thing we're going to want is a storage where we're going to put the data that we've calculated. This thing's going to calculate data every time it's called, and that data is what you need to send to a client for it to be understood. So let's have a quick glance at an existing one. So I've got something called a full serialization. This is this one was a pretty weird world, I think. Serialized. I had something called serialized ship. And what do I do with this? Implement this serialized ship. I think I made a component as well. Okay, so we just had a... Oh yeah, so the serialized ship was a resource, and we made these things called chunks. So this is how the floor inside a ship is sent over the network at the moment. So we have a system that processes and creates the chunks when the ship changes, I think. And then the other one sends them, something along those lines. Oh well, this will be a useful reference later on. So usually at this point I'd slice it off. I'm just going to pop it, I'm just going to literally drag it off into the other screen. So if you drag it off, you get a little window like this. But that window is not for you. And it's not for you just because I don't have enough screen real estate to keep that handy. But I'm going to return to that later, so I'd quite like to have it on my monitor. So when I'm usually working without you guys watching, all the fonts are smaller, and I have windows everywhere, you know, like on all the monitors. And so these two you can see here are full 25,000 pixels across the bottom. The one above us here is a 4K monitor, so, you know, but when streaming I have a bit less real estate. It's worth it. Populate sender server. Yep, this is a different thing. Space. System engines. I'm sorry, I've got myself lost now. Space serialization. So we're going to create a new system, a new resource here. So a resource just looks like a regular structure, and that resource is going to be serialized space, right? And all it does is contains space snapshot, which is going to be a vec of U8, like so. And it's vec with a capital V, and it will require importing. We'll make that public. Oops, I don't need a semicolon, that's what's wrong. Obviously, it's not going to tell me it needs importing right now. Use std vec. No, it won't tell me at all. Okay, so this resource, I wanted to register this resource. In fact, let's just do that now so that I don't forget. So we're going to close everything else, close others, and we're going to open space.rs, and inside this I have kind of a funky little structure, a little class that is just, I call it a world wrapper, and it's where I create, it's got a little factory in it for creating the right world, and I need to register two new things. So you remember I created a component here called network entity, so I need to register that there is such a thing as a network entity. And the other thing I need to do is I need to create a new serialized space instance. So if I looked up space, and in here I got spaceships, this one, I've got all these useful things that I tend to derive from most classes in here. Boop. I need to derive those for these as well. I don't really need kind of no harm in having these. Equal and partial equal seem kind of redundant. Copy and clone. Let's not make it copy, just make it clone. Okay. So copy means that you can transparently copy it without even like any warnings or having to like say, I want to copy this thing. If you got a whole vector, it seems like a bit of a waste to be reallocating memory by accident, so I'll just make it so you have to specify it. So I've got this, I've derived default, and default will return a serialized space using the default constructor for space snapshot, which is an empty vector. So we go back to space, and we're going to, where is our little factory? Here it was. We're going to insert a default version of this. So world dot serialized space, so dot insert serialized space, and this function is called default with a capital, with a lowercase d, like so. You know, the other capital, the lower one. This resource is like a place all the components can see, all the systems can see, I mean, when they ask for it. So one thing we're going to need here access to is being able to write to a serialized space instance where it belongs to the world. I need a comma. Comma. So those are all the things that the system currently needs. It needs to write to serialized space. It needs to read a pos, biped, and spaceship. These are the things we're going to sync. It needs to write into a network entity. Now, if I look at pos, biped, and spaceship, none of these know how to serialize themselves yet. So I think if I jump into biped, it doesn't know how to turn all these values into stuff on the wire. But fortunately, I believe every single one of these already has serialized defined. So if I had a look at production module, I don't think I did. I defined serialize and deserialize here. So we can actually just go whack, and assuming it compiles, Fix64 has got serialize and deserialize, global world ID. This is just like a 64-bit number that is a fixed point. So that should serialize. That means like we can turn it from being a value that Rust understands as a number that you can use in the CPU to just a string of bytes that we can send over the network. And then the other end, the deserialize, turns it back into a struct. It's kind of magic. Even if you know what serialize and deserialize usually do, it's really nice how it takes care of it for you. So if you don't know about this, have a look at the Rust library called serde. Oh, by the way, shout out for myself. This is my Twitter. Recall Singularity on Twitter. That's the game I'm making. If you have a look at serde, this library takes care of serializing and deserializing various structures, enums and stuff. So all the network code in my stuff is using serde, and it's using a particular one here called bin code. And at the moment it's just using out of the box pretty rubbish defaults. The bin code does a pretty good job, but what I mean by rubbish is that as we go along later on, some months down the track, I'll be writing custom code to reduce the amount of data even more. Like I should be able to save like half the data by making my own custom serialization. Where can you find the Discord link? Let me make a fresh one for you. So recall Singularity, you probably want to go to go.rust, they're all the same. Go to invite people. To answer the question, if you had actually just searched recall Singularity Discord, you probably would find it. Edit. Max number of users, no limit. Expire, never. Generate a new link. Here it is. And paste. Enjoy. I'm delighted you'd like to join us. You'll find Toast Eater is already there. Yes. Okay, I'll just put that aside. Oh, there we are, Carofel. I'm just going to quickly give him a role. He's an instant veteran because he's just so helpful. Anyway, it's so nice to see people. I really appreciate all my followers. I appreciate all you guys cheering me on. It's kind of weird watching the number, like the speed of people joining increase over time. For a while it was a bit like, hi, I'm over here, and now it's like people are just flowing in all the time, and it's like, I guess this is the new normal now. The biped. It's cool. Thanks for coming to join me. Really cool, like trippy cool. System. So we're going to write the system. And all of these types that I've just specified here are going to get passed into this run by specs magic later on. And so let's unpack them real quick. So the things we want are a mutable serialized. We're going to get some positions, which is not changeable. We're going to get some bipeds. We're going to get some spaceships. Let's just call that ships. And we're going to get some network entities. Let's call it net entities with an underscore. And this one has to be mutable as well. So those are the different things we're going to get out of the system data. So you'll notice that each one of these, that first one corresponds to the first one here. That one corresponds to the second one. This one corresponds to the third one, and so on. Now the next thing we need to do is we need to do something called a join. So if you go into the specs documentation, so on docs.rs, go to specs, go to latest version, and I actually want to go to the book, so link to the book. That link to the book didn't work. Let's try again. Here, go to Git, and this link to the book has worked in the past. Okay, there's something called joining components here, and it tells you that if you take references to components, you can iterate over them. It's a very nice little bit of magic. And there's optional ones as well. We're going to use some optional ones, and to make them optional, what do we do? Mass storage. Oh, there was a way of doing it in a cool way before. Like something called option, or a question mark, or something along those lines. Let me just open the window, hold on a second. The answers will flow in through the window. No, unfortunately, just moths. Anyway. It was nice to see you, Carafel. Have fun for your university study. Catch you later. Hold on. Run. So how do we get an option? Because I believe there was a really cool way of doing it. It's suggesting here that you just use a storage, right? Hold on a second. I'm just answering an urgent Skype message. Run. What are we doing here? Okay, so I'm pretty sure there's something called option or something along those lines. Dot option. Well, there's a question mark involved. Where you would do a join with a question mark next to it. Huh. Ugh. What would I have done which had an option? Yes, the other serialization I was looking at earlier, this one actually uses the optional thing in it. A bit further down. Here. Yeah. So you just wrap the things you want to know about in some? No. In this case, I'm using components.data get data components.get. Yeah, it was this thing called maybe. That's the one I couldn't find in the book. That's what I'm looking for, is this word maybe. This approach is really interesting. It's I don't really want to walk you through all that code, but one thing I really like about doing a project over a long period of time is that you wait long enough, and you come back and revisit your old code, and if you've done well, you're like, oh my god, old me was really clever. How the hell did he do that? That's really cool. You'll find, if you're like me, that only started happening after you've been programming for like 10, 15 years. Up till then, it'll be like, oh my god, old me has no idea what the fuck he's doing. He's like the worst coder ever. Don't worry about it. It'll get better if you keep working on it. I made a recent response video to Raphael, who makes that Planet Cleaners. I think I mentioned him earlier. If you're watching, you would have seen me mention it. That response video, basically, he was beating himself up about his programming skill, and I'm like, no man, you've made all the right choices. You've just dug in and made a game. who cares if the code's a bit messy? That's correct. Making messy code is actually the right way to go about it. One thing that I'm doing for this project is a little bit overthinking it, but I'm trying to make a clean infrastructure to start with, because what I'm planning to make is going to be so complicated that if I don't get it right, I'm going to not be able to finish. So anyway, but I'm still hacking it up a little bit. What are we iterating over? We're going to go for, and we're going to find ships. So we're going to find these different things. We want a pos. We're going to definitely get a pos. We might get a biped. Biped opt. I'll just put opt here. We might get a spaceship. Opt. And we might get an entity entry. You'll see what that means in a minute. Those are the different things we're going to iterate over, and it's going to equal positions with a reference to it, like this. So we take a reference to positions. We're making a join statement here. We're going to make a reference to positions. We're going to take a reference to, I don't think we have to make a reference for this one. We're going to go bipeds dot maybe. Let's quickly look at in the example I didn't use a reference symbol. Ships dot maybe, and net entities. We're going to use something called entries. And so entries is going to make it very easy for us to add a new net entry to those things that don't have one already. My cursor's doing weird things. I can't get it back off the other monitor. It's stuck. Oh, there we go. For those things, in those things, join, make a loop. Okay. Now we can think about which particular situation we have. So how do we do this? I think we'll probably find that serialize, I wonder if option already has a serialize. We could serialize a bunch of masks, like a mask of what things exist. That's probably the easiest thing, is to serialize a mask of what things exist. So we've got a pos, a biped, and a spaceship. So let's just do that. So a constant, we could just make an outright requirement that position must exist. We have already made that requirement because here it's not optional. So in case you missed it, if there's no position, we're not going to send it over the network. It's just not going to happen. And it might have a biped, and it might have a ship. So we only need masks for bipeds and ships. So the biped exists flag. Flag. Biped exists. We're going to define the hexadecimal number 1. So there is 1 bit set in 1 at the first position, and this is going to be, for now, a U8. Type exists type, and we're going to make that a U8. I think we use an equal sign for types. Great. So flags. Make that a U8, like so. Okay. We want the next one is going to be whether ships exist. Ship exists. And that's it. Those are the only 2 we have. So that's 1, 2. The next one would be 4, then 8, then 16. And 16 you'd represent by putting an A there. No, you'd put a 1 to 1, 0. Because that's hex. A is 10, not 16. Silly Tom. Biped exists. Great. Okay, so we're going to want to serialize the information about this particular thing. How are we going to go about doing that? Okay, net entities. So something is going to have to count up through all the entities, network entities. We're going to have to say this is pretty much the only place we set them. We might just go for the very simplest thing, which is just to count them as we serialize them. So let's just say network ID counter is a U32, which should cause really exciting things to happen if a sector lasts long enough and the game lasts long enough. We get 4,000 million things in a sector, the ID is going to roll over and really exciting things are going to happen. The other option is to use the entity ID number, which is actually probably a lot better. Yeah, let's not do that right now. Okay. So we're going to say, first thing we want to do is let net entry equal, and this is going to be end up being a mutable reference. I'm not sure if we have to declare this as mute, probably. And we say net entities, this is something called a maybe, or default, I think it's called. Or else default. We need to find the last time I used .entries as a quick example. Here I used it. Oh, I just found the very code I'm working on right now. It's not a particularly good example because it's not finished. Here we are. This is what I was looking for. Something called or insert with. Right. So, or insert with, and this needs a function that's going to return a new network entity. And so to create a new network entity, let's make a little block. So the first thing we're going to do is we're going to say take our pointer to serialized and access the field called network ID counter and increase it by 1. And then we're going to return a new network entity, and in that network ID entity we're going to put an ID, and it's going to be equal to serialized.network ID counter. So that idea here is that every time we have a new entity to send over the network, we're going to give it a number. First 1, then 2, then 3, then 4, then 5, then 6, then 7, all the way up to a very large number. 4,000 million to be precise. Ish. 4,000 billion, I mean. Which is max int for a U32. That's great. So that's, and what's nice about this is it will immediately put it into specs as a new entity. So this is how you create this guy. Now, how are we going to serialize it? We need a serialized structure. Let's again consult my other example. So I'm creating this thing called buffer, and I can specify to resize the buffer. Here I put the mask in first, which we might as well do here. So we resize 1, and this is really size of, is it size of? It's probably going to be exists flags dot size. I was thinking I could just use size of or get size. Ugh. Okay. Oh, basically it wants Rust U8. So I basically need number 2 or 1, but I just want to get it from the code so that I don't have to worry about it later. Size in bytes. I'm not sure how to figure out how long this thing is. Ugh. Let's not worry too much about it. I need to put that browser window back, actually. Yeah, the one I just got rid of. Because I want to keep watching you as you watch me. It's always nice to see that people care. Excellent. So I'm just going to hard code this number, and my unit test will fail when someone goes and messes it up, so that at least will save me. If you're joining me recently, you might not know that I'm coding to fix a unit test here that is synchronizing the little spaceships that are in my game, so that it gets sent between server and client. But at the moment, I'm not creating any messages that tell the client about the spaceships. And in the process of solving that problem, I've decided to create a whole system that can serialize positions, bipeds, which are the little people, spaceships, all those things in one go. And over here I have a reference, which is a previous serialization I've done, which is the floor of a factory ship. That I'm not going to really explain, but I'm kind of picking bits out of as I go along. So I can't remember how to do this, so I'm just going to put a 1 here, because I know that bytes are 1 byte long, which you might find very surprising if you think about it for very long. Of course, bytes are 1 byte long. What do you take me for, sir? Do not be ridiculous. Have you ever found a 2-byte byte? No, sir. That is a short. Or a U16 in Rust parlance. Maybe an I16. Oh, my friend, there are so many variants of this thing. So here we resize it. So that's going to leave 1 byte free to specify which things are in it. Next thing we want to serialize is going to be the network entity. So I need to make sure that I've got this other serialize and deserialize here. Those will define some routines to turn them in and out of binary, which is very useful. Yes, I did that right. And if we have a look in here, we can see how it's done. Something called serialize into, and we put it into a buffer. So it appears that whenever you use serialize into, it just adds onto the end of the vector, which is like absolutely perfect. Oh, so wonderful. So let's just show this. If let some biped is equal to biped opt. So if there's a biped on this entity, we want to serialize the biped into the buffer like this. So I need to import serialize input into import u. It's going to go into buffer, which is this vector that we're not making. So let's interesting. Just ticking through my head whether I want to put a prefix on this data, because I'm thinking we probably don't need one, so we won't bother. We want to work with a buffer. Let's create a new one. So let's send, well, we don't need to create a new one. We can always just keep reusing the same one. So let network, we're going to unpack serialized space here. So we're going to let serialized space, we're going to take network ID counter and also space snapshot. We're going to take them from serialized, we're going to unpack it, equal to a mutable reference to serialized, like so. And so what we've done is we've got these two mutable variables locally out of this structure here, and so that means we can independently use either of them throughout this function. So this unpacking is nice. If you knew much about Rust, you'd understand that otherwise we can't just keep using serialized.network ID counter and then serialized.space snapshot and keep swapping them, because it'll eventually get angry about the ownership consequences of doing that. But with what I've just done there, we can just refer to them directly as these variable names, and it should work throughout. So first thing we want to do is clear this buffer. So now this snapshot's the clear buffer. We go down into here, into this code. We want to leave some space for the mask. The next thing we want to do is we want to serialize into, and the thing we want to serialize is going to be the entity entry, the net entry that we've created. So we serialize that into this guy. like this. And we're going to say unwrap because I expect it's always going to succeed because the serialization of this class is very simple. Great. Having serialized the net entry, which is really just going to be a single number, it's going to serialize 4 bytes containing an ID number in something called little Indian format. So the first entity will be a 1 byte, then 0 byte, 0 byte, 0 byte, and then next thing it's going to serialize. So before that, it's going to serialize a single byte, which is a mask containing some bits saying what things were added to this entity. So if let some biped is equal to the optional biped, serialize that into the buffer. So if we've got a biped, we put that in, and if we have a spaceship, we put that in. And so here what we're serializing is, that's the biped, that's the spaceship, and if you've been observant, you'll know that we have to actually update the mask for each of these two things. So we're going to track a mask here, let mute mask equal, and it's one of these things, exists flags is equal to 0. We don't even have to specify the type as exists flags because Rust will actually figure that out. So here we want to OR in, so we're basically setting a bit in this mask for biped exists. Let me just move this so that you guys can see the chat window hasn't got anything in it. But you can fix that. If you just open it up and start chatting, I'll answer questions you might ask. As far as I understand, you might need to log into Twitch for that to work. I'm sure you'll figure it out. But any questions you have, I will happily answer to you. So, mask. Biped exists, ship exists. It would be my pleasure. And we also have to serialize this thing called position. Pos. Now, I'm not sure if pos is easy to serialize. So I imagine we have to create our own version of serialization for that, or have a structure that we can copy the data into, or implement our own serialize and deserialize functions. Now, unfortunately, I don't know enough about how to write a deserialize and serialize function. It tells you how to do it in documentation. But it's kind of scary implementing serialize. Serialize I32. Serializing a sequence or map. So what we want to do is serialize essentially a tuple. Serializing a struct. Have you heard of Rusty Object Notation or RON? Yes, but I'm using bin code, which is even more terse than Rusty Object Notation. So this wouldn't be good for network serialization because it's too large. It could be good for configuration. That'll be something for variables down the track. But I can't let things get that large for transmission over the network. I need them to be much more packed than that. So, for instance, I don't need to know that I'm sending window size. I could just send 2 bytes for these two numbers that are both less than 65,000. And that's a lot less. That'll be less. These two characters here are either 2, 3, or 4 bytes, depending on how they're represented. So it'd be much more efficient. But that's a really cute representation. I hadn't seen that one before. Something to consider when I'm next thinking about what to put my data in. Because I was thinking of using a different one, not Ron. I think it was Ron, but it was There's another one that was mentioned by Serdi as being very Rust-like. So the serialize, that reminded me that I don't have to write a serializer, I just have to whack it into a tuple. So for pos, I just need to create a tuple that contains all the values I want to serialize. So if I want to serialize pos dot 0 dot translation, I might just have a look at some reference code I've got in sgcore source components entity move. This is part of my specs to Godot synchronization code, and it unpacks the position, and so I thought it might be a useful reference here. If you want to use that synchronization, it's all in Git. I can give you a link, or you can just search for my name, Tom Lees, on GitHub, and have a look what I've been up to, and you can see on there this open source MIT license synchronization between specs and Godot, which is nice. So we want to send the translation in X, like this. So we're going to send the translation in X, the translation in Y, the translation in Z. Then we're going to send the rotation. So the rotation has got 4 parts to my knowledge. I don't think I can just turn it into... I prefer to send the quaternion in its raw form, which contains 4 floats. I'm not sure if I can get that out. It's something called a unit quaternion. And it's in Euler. Let's have a look and see if that finds the right one. Rust. And if not that, I have to use docs.rs. In algebra has a unit quaternion. Okay, I must have been confused. Yeah. 4 coordinates in the U, Y, Z, W storage order. Let's see if this will work. So we've got 3 translations, and we're going to want the 4 rotation X. Let's just check across here in this entity move. It is called rotation. Yes, that's good. Okay, rotation X. Rotation Y. Rotation Z. Rotation W. So the maths for quaternions is very funky, and I don't need to understand it. I don't understand it. It doesn't matter. I just use the functions and it works. They're for rotating things in 3D. So we're going to send all 7 of those floats. So each one of those is 4 bytes. So that's going to send 7 times 4 bytes, being 28 bytes for the position. We could probably compress that a hell of a lot. I don't care enough at the moment. Potentially we're going to send a biped. Potentially we're going to send a spaceship. Once we've done all that, we're going to take mask and put it into buffer. Buffer 0 is equal to mask. I think that in my other code I did that by serializing it in to that location like this. So let's just do it that way because it seems cool. So here we reserve a byte for the mask. Here we write the 4-byte entity ID number. Then we write position. Then if there's a biped, we write a biped and we set a flag there. And if there's a ship, we write the ship in and we set a flag. Finally, we go back and we write the mask in so we remember which flags were set on the receiving end. This system should create a little block of data for ship space serialization, which is kind of cool. So, in order for this to actually do any work, I'm going to need to call it at some point. One option is to call it every frame, every tick. Not necessarily required. Another option is to call it just before we send the data, which is probably what we're going to end up doing. I think the quickest and easiest way to actually see if this is working, first we're just going to make sure that that's correct. And network ID counter. What's wrong with this? Okay, so it's complaining that for some reason it's different. I need to use a star here to dereference it. Great. I mean, I could just be really explicit and just say clone. I kind of like that. Just say we're copying the variable into the struct. Pull this back across. Okay, so what I was just discussing was how we're going to test that this is working properly. Well, we've got a nice little example here which creates a ship. Let's just grab all the tests from here and jump back across to here, paste that in. Now, this ship creation test creates an entire sector. We don't need an entire sector, we just need space new. How do I create a new world? A whole new world. I use something called build. Where have I called build? Here we go. So I've got a test here for changing colliders. This is how I was testing to see if the floors would update on my spaceships as I changed them. And here's how I create a very simple space world, add a spaceship to it. That's exactly what I want to do in this example. So for our serialization, we're going to create a simple world by calling my world factory called space. So remember, that's where I registered the component earlier. Give it a world ID of 1, give it a spaceship, and we'll just delete everything else in here. And then what we need to do is we need to ask the space world to serialize itself. So let's just say we create a new function called serialize, right? And it serializes itself. It could be very smart about how it does that, and it could cache things, and all sorts of neat things could happen. CRILYZD equals that. Now I've got something to 2 bytes, or to byte array, or I've got some function somewhere that turns an array into bytes. I've used it in my network code. Let's have a quick look in here. Source. In the server I definitely use it. Binary. Decode packet. Process message. Where are you, my friend? My little byte-wise friend. Try and find old code. Where is my old code? Lib. Come on. Don't let me down, I'm on stream. Everyone's watching me. Look for you. It's possible that I took it out during some refactor. It'll be something like this. Yes. Byte string. Oops. It was a symbol called byte string, and I've put it in my tests in the past. Here's one here. I put it in this file called test. So take a slice of U8s and iterate over those, map them all to hex, collect them together, join them with a space in between. You've got a little hex dump. Nice and easy. So we're going back to our space serialization class, and in here we got our serialized data by calling space serialize, which is an imaginary function that doesn't currently exist. We're going to assert equal, and I'm going to say it's not equal to anything, but soon we're going to find out what it is equal to, and we're going to use byte string. serialized. If you pass a reference to a vector to something, it can be coerced from a reference to a vector to a reference to a slice, because that has been implemented as part of into from some other cast that's available. Anyway, I think it's called deref is the one you have to implement to do it automatically. So import space. Now, this function called serialize doesn't exist in space, so let's scroll down a bit and make it. Function serialize. So what does it need? It takes a world. A mutable reference to a world. It needs to be mutable because we're going to modify those resources that I've just talked about. And it returns a vector of U8s. Right. If the world is a mutable reference to A, then the vector of U8s is actually a non-mutable vector, also sharing lifetime A. We're going to say that this, and this is probably the default for references, but I'm going to say it specifically. In fact, it's probably going to tell me I don't even need to say it. Yes, that's elided, so I don't even need to mention it because I've only got one reference. Oh well. It's going to return a reference to the vector. And which vector is going to return a reference to? It's this one in here, in the serialized space class. So to return the reference, we just go world.fetch, and we fetch the serialized space class, and inside of that we fetch this one called space snapshot. So I need to put a call, I need to specify a type. Done. Hopefully it doesn't complain about the way that this fetch returns some sort of guard object and that returning a reference to it is not good enough. Yeah. Probably won't compile. Anyway. In order to actually, for this to contain the data, we need to run now. Space serialization, we need to run this class. So we say world.run now. We specify the class we want. Sorry, it's the other way around. We go space serialization, run version, an instance of it, run now, and we pass the world like this. And doing this, we'll call this run function with the right data. Serialize. And it's complaining that I haven't specified that I've got this in the wrong import block, so I'm just going to move it down into the stuff that's not in a template. We've got a trait for these worlds. Got a production floor and a space world, they're both input from a trait. Don't worry too much about that. Lots of compilation issues, so much fun. Add spaceship, we haven't declared what this is. It's in lockstep. No, it's compiling for longer. No. Doesn't know what a serialized space is. Okay, so if I go and have a look at this, I bet space serialization, everything in here is private. So we need to make this pub. We need to make this pub. And they defined that there was a space serialization stripe. No, we need to make that pub. We'll move this down to match with this one. And then we need to go, space serialization is first mentioned in spaceship, which is here. I need to say it's a public mod. Home. Pub. And then each of those locations that didn't compile, I can now import things from. So this red means it's importable and it can fix it in the editor. And so as I use each one of these, C-liner's hand is going up here and somewhere, and it's adding this line for me, so it's saving me some time in typing. Cannot find buffer. Okay, so I didn't call it buffer. And call it space snapshot. So we're going to, the way this works is it's constantly resizing the entire buffer. That's, yeah. Let's make a new buffer. Equal vec. So we create a new vector here. We resize it, we fill it up. At the bottom we say space snapshot dot append, and we specify another, which is buffer, like so. And if you have a look at what append does, is it actually drains. It moves all elements of other into self, leaving other empty. See how here we end up with a vec contains data and vec2 is empty. So we drain the buffer here. But what's great about this is that buffer is left as a pointer to a block of RAM ready to fill the next packet, and it'll be about the right size. So, you know, that's pretty awesome. Now, we need to say here that it's mutable, otherwise we can't change the buffer as we go along. Oh, and down here we need a mutable pointer to it. Mute. Cannot find. Okay, I just need to. Got this thing called a ship box that's kind of not needed. I probably should stop bothering with that here. Cannot find space serialization. That needs to be imported. What's wrong with this one? I need to take a reference to this thing. Intrinsic size of. I didn't actually use that. Seems to be an unstable library feature, so maybe it's better I didn't use that. Serialized space. Okay. So we've got a write. Do we have to do something with that write to actually get it out? Let me have a quick look at the documentation for a write, which is part of specs. Find create specs. Here it is. Write. It's like a little container for holding a resource. And if you deref for T, you get T out. So what it's saying is that here I need to deref. It returns a deref mute. So is that a mutable deref? Let's have a look at what it implements. Okay, so we need to use a star. So if we just put a star here, that should work. It doesn't want to move it, which isn't surprising. Okay, that's not exactly what I want to do. I've seen situations where you can create a mutable reference to a dereference for you like this. Let's see if that works. It doesn't seem to be worried about it anymore. Well, we'll see if it blows up later in the compilation. Method not found in storage. So rather than net entities, I need to say entity entry here for that to work. No field X. So the quaternion doesn't let me look in. It doesn't give me any clues either. I wonder if this unit quaternion requires me to actually use some other API to get in. I was in algebra before I went to specs, wasn't I? Yes. So there's something called a vector and something called a scalar. We could use as vector. Lots of other words. Use a new function which takes Wij. Is that what it's calling them? Do I just need to say Wij? Let's try Wij and see if that works. Wij. Wow, okay, cool. So that's what the internal quaternion fields are called. That's nice. Binary assignment operation plus equals cannot be applied to a mutable reference, which is not surprising, only a little star there. Mismatched types. Expected a reference type. I can give you one of those. Trait bound starship is not satisfied. So it's saying spaceship doesn't have, I haven't added a derive on that guy. See here, there's no serialize or deserialize. The one I currently need is called serialize, so I need to put that on the front here. Great. Method serialize is private. Well, that's easy enough to fix. I forgot to put a public on the front of this one. Pub. Oh, and it won't work, will it? Yeah, because I need to pass the world in as a mutable reference. Mute world, right so. Yeah, that's the only thing it complained about too. Let's find out what's next. This is when the borrow checker smacks us over the head, right? Variable does not need to be mutable. Great. Okay. Cannot return value referencing temp. Yeah. I was worried that was going to happen. Called it. Okay, well, what do we do here? We could just return another Vic. Requires copying some data. I'm not a huge fan. The other option is just to move this code out of here back to the calling code. We might just do that. So it returns vec, which means it returns spaceshot.copy clone like this. So that will compile, and it could be that later on, if I wanted to avoid a copy, I could just copy this code back into the calling function, or I could create a wrapper class of some kind. I bet there's a whole bunch of smart stuff I could do there that I don't currently understand. To avoid having to write a whole wrapper, that'd be nice. Because, you know, then I have to like get those like dollar bill chains and stuff. Okay, so this test has failed. The test I actually care about. So right now we're not actually running everything. Run. I've got it set to only run one test. Fortunately, I don't have to compile again, just to run the test again. Come on. So we should see two tests fail. So one of them's to do with the space serialization because I haven't specified. Oh. Error. Failed to write whole buffer. So which one did it fail to write in? Probably that U8 at the end, where I specified a slice of a limited length. It's trying to put it in the buffer, a net entry. I'm probably misunderstanding the arguments I need to actually write this in. Serialize into. Serializes directly into a writer using the default configuration. If the serialization would take more bytes than allowed by the size limit. So I don't think there was a size limit. Yeah. Because net entry is actually a pretty simple little class. Should just be a reference to, by the time I get here, it should just be a reference to this, which is basically just a single number. Serialize into. Yeah. I'm at a bit of a loss about that one. So at this point here, I'm expecting it to be just a mutable reference to one of these guys. Let's just write that expectation out. It's one of these. It's a mutable reference to a network entity at that point. Seems to be compiling okay. So it is the type I thought it was. Yep. There's something funny going on about this here. So we get empty buffer. We resize it. What does resize do? Resize the vacuum place so the length is equal to new len. And a value is used. So that's correct. I mean, I was expecting if it was going to fail, it was going to fail here where we have a buffer of a very specific size. I'm at a loss as to why that doesn't work. Because I was expecting it was going to grow the vector. See, in this example code, very similar behavior here is working okay. In each of those cases, I'm serializing in a numerator rather than a structure directly. That's easier, maybe. So one possibility is to just use a debug statement, debug, and serialize directly this net entry. So let's output a serialize call that takes net entry as a value and see what that does. So let test data equal this. That should return a vector containing a serialized version of net entry. Output the test entry. Import serialize, which should be right there next to serialize into. So serialize into takes a writer and some data, and serialize just takes a vector and returns it. Yes. Then we're going to output test data, and we'll just see what this looks like if I run that again, just this one test. Run him. Run the test and tell me what's wrong. Okay, so it ran the test and we got out exactly the 4 bytes I was expecting to get. A 1, a 0, a 0, and a 0. However, when we try to call it here, doesn't want to add data to the vector. I think the problem here is that the vector isn't large enough. So if I just said 100 here, and I ran this test again, so now we start off with the vector being nice and big. Would that just work? Yeah, so in this case, let's actually go on ahead and serialize this data. So here's our mask. I wonder if it's being fussy about the data being aligned to integer boundaries. Seems somewhat possible, but very annoying. 100 is not, oh no, 100 is aligned to an integer boundary, because it's 20 times 5. 20 is aligned to an integer boundary. Yeah. Okay. Does that mean if I change that from a 1 to a 2, would that work better? No, it's still failing to write. Is it failing to write in the same place? Yes, right in this net entry. How about 4? This is very peculiar. Is it complaining because the vector needs resizing in order to fit the data in? I was thinking that, let's say reserve, which specifies how large the vector is to start off with. So if we say that the vector starts off with 100 bytes of memory that's addressable, does that fix the problem? It doesn't want to be writing halfway and it has to resize the memory. Seems pretty plausible. No. I'm getting quite peeved actually. Okay, so resizing the vector to be, say, 32 bytes at the start causes the other things to work. Has to be a crazy number here for resize for this to work. Might be that reserve isn't helping at all. Okay, so if I make this array 100 bytes long, so we have should have 100 bytes of nothing useful. But there's not 100 bytes of nothing useful I'm seeing here. There's actually quite a lot of bytes, and then there's some ifs, which I mention as our data, part of our data, which is in itself really odd, because why is the data in that location? So I was expecting it to append onto the end. So maybe there's something I'm missing here about what this definition of buffer is. I thought buffer was just a regular vector. So it's a mutable, here it's a mutable reference to the vector. Down here, do we change it? Buffer. Not that I can see. Yeah, using the bin code one. Yeah. This is really mysterious. Let's just take out this particular serialization of the net entry. this variable from up here. And leave this other stuff here, and we'll change this resize. We'll change it to a 1 again, which is the value I actually want to put in the resize. And see if that works. So we've got another fault. Where are we? Here, serializing the very next thing, we have a fault. Failed to write whole buffer. So, partially this is because I'm being very fancy and trying to write it all into the one vector without, I could create a whole bunch of temporary vectors and then copy them in, but that would be like ugly. So these are all the different things you do to a writer. And a vector can be a writer, I know that. Is it because I didn't specify what buffer was? I mean, it's determined that it's a vec u8. I mean, I could just put that here. u8. Sorry if I'm boring you to tears. Hopefully this debugging process is educational. We don't need this test star to serialize. Unwrap failed. So here's where we start a panic. So we'll put a breakpoint in that. We can right click on this and say debug. And we'll just have a look through the debugging state and see if there's something in there that's going to give us some clues. Okay. Debug mode. I think it's actually gone all the way to the end of the process without ever actually hitting the breakpoint, which is interesting. Probably because it's a macro that I've highlighted as a breakpoint. So unwrap failed, unwrap. So what if we put a breakpoint in this? We'll just try running that again. That didn't catch it. Put a breakpoint up here at the start of unwrap. See if that works. Still doesn't want to catch that breakpoint. Okay, we'll go a bit further up. So in run, the problem happens here. We'll put that breakpoint here. It's probably a pretty obvious place for it actually. In retrospect, oops. Yeah, it's saying it failed to write the whole buffer, but as far as I know, it should grow the buffer as it goes. It shouldn't have a problem where the buffer's the wrong size. Step in. Oh, yay, assembler. So it's in the vector code, getting a vector 8. This is a dereference, serialize into is what we want. No, because we're not writing into a socket right now. We're currently writing into a vector, a U8 vector. So it's just a blob of data on a pointer. We're creating a new configuration for this write. So we're going to use unlimited, I imagine. Frames and variables. Where are the variables? I think there's a draggable area here that's hidden somehow. Variables, I see. So we need to have self. Or not. Anyway, so great, we're creating a default config. Serialize into it. Unlimited and little endian. Great. Serialize into this. If the option is sum, but there isn't a limit, so create a new serializer and serialize into it. Okay, so we'll put a breakpoint here so we don't have to step through that stuff again. Okay, so this is the derived serializer being called. So it's going to serialize a struct. The name is, it won't tell us what the name is, and the len is 1. Okay. I'm not sure why we're exiting now. We seem to be exiting out. Where are we? We're into an unwrap function maybe? This is when we discover that we're currently panicking, I think. So if I look at the console output here, it doesn't show the panic yet, but that's what we're currently doing. So, and then we get panic written out. So how would we figure out what was going on in there? I'm pretty sure it does, because in other code, it's acting like it does. It creates something called a writer out of the vector, and then that writer is able to grow. There's something called a buff writer. this thing called a buff writer that wraps around the writer. I mean, maybe we could try using a buff writer over a vector. There probably are other options. What implements write? Implementers. See, there already are there's already a write implementation for vec8. See, and write is implemented for vec8 by appending to the vector. The vector will grow as needed. So that's the option that I'm trying to use right now. Source. Write for vec8. So it's kind of mysterious that this isn't working. And write is also implemented for mutable reference to U8. In which case it won't grow. I copy it into the slice. So it's possible that by saying that's probably what's wrong. Buffer here. Yes. Okay. That is a problem. Thank God. Oh, thought it was going to be insane. Problem is that this serialize I have been using as an example. It's got a variable here, a buffer as a mutable reference to a vector. Yeah? And down here in my example, I'm constantly dereferencing the mutable reference. Up here, buffer is not a mutable reference to a vector. It is actually a vector. So everywhere I say star buffer, I need to just say buffer. By saying star buffer, I'm probably turning it into something else, like a slice. Or something similar. And that's no longer a writable one, it's just one of a fixed size. And then it probably is writing all the data in the same location. So this should actually work as intended. Let's try that one. Thank you for sticking with me through that process. Hopefully you learned something. That's what I always try and remember when I'm having a pain on stream. It's like, yes, my friends who are watching me are learning things. I didn't need to run it in the debugger, I just wanted to run it. So just run over here and see that serialized. Now, yes, so your conversation word constructor, although you didn't specifically specify exactly what was wrong, it was still really helpful because it got me thinking on the right lines. So I really appreciate it. Thank you for engaging. Yes. Yay! Okay. Here we see the data we want. 2. So we see a 2 because there's a ship and there's not a biped, right? Next thing we see is network ID 1. That is correct. The next thing we should see is a position. So the ship is currently at 0, 0, 0, and then we see a rotation. So these 12 bytes are going to be the rotation data. And then there's lots of zeros for the ship itself, which has no data in it. And so that makes you think that in our test, for it to be of any use, we need to actually specify some positions. So let's go back into, I'm starting to fade quite a lot. Let's go down here. So where do we add a spaceship? We're going to specify it from a float. 1.0, 2.0. That's the X and Z coordinates and its Y is 0, I think. Yep. And its rotation will be nothing. The ship box, we're not going to specify that it has an empty ship box. We're going to specify using the new function, which is how it's transmitted on the wire. So ship box new, and the ship box is going to be 1, 2, 3, 4. The world ID is 1. I bet that 1 is here in the data somewhere. It's probably this one here at the end. Oh, that's another reminder, is when we synchronize the ship, we'll probably need to synchronize its floor at this level as well. But let's not worry about that right now. So if we run that, so same thing here. I bet that that's a float containing a 1, and I bet that that is a float containing a 2. Although if I had to guess, you'd think that this float here would start with a higher number, would be opposite. Oh, these are 64-bit floats, of course, with a fixed portion, and x is first. Yeah, so it's going to be, this whole thing is going to be the number. Anyway, I don't need to comment on that. Ship box is along here, so you can see that's the size, the dimensions of the ship are there. Okay, so we're going to just say, okay, that is the actual data. So I'm going to copy it out of here. I'm going to paste it into this, like this. So this is something called a golden data test, where we just say, okay, well, I don't really care what the data really is. I just care that it doesn't change later. So this test is going to sit here as a sentinel, and if for some reason we change the representation of the data, unless we screw up, this shouldn't change, basically. But if it does change, we have a good reason for it, and if we have a good reason, we just put the new data in. I'm just checking that it actually passes now. Okay, so there's some off by 1 difference in my data. There's a place here where I've missed spaces, so where I've broken it across lines. I think it's stripped this leading white space, but I just need to add a space here to make sure that the byte spacing is correct. Come on. Yay! Little tick, got a passing test. That's wonderful. Okay. So now we need ship deserialization. Yay! So ship creation. So this isn't really a ship creation test, this is a ship serialization test. So it's space ship serialization. Space serialize. IALIZE ship. And down here we want to create a space deserialize ship. Deserialize ship. And this, my friends, becomes our input data, like this. So let input bytes string equal this. Right, so we've got a byte string function, and I've got another one called from string. We've got a hex string, which is the output of this. So decoded for as byte in the hex string. If it's a hex digit, we add it. So, and if it's not a hex digit, yep. So I'm using the idea of some and none to represent whether we've got 1 digit already stored. So we grab, if we've got no digit stored, we should have a space, or we could start the next digit. It's flip-flopping. It's a little bit hard to explain, but this is doing the decoding, exactly the decoding we need to turn this back into a series of bytes. So our input byte string is that. Blip. So our input bytes is that. We'll just call the function straight away. From string. This whole thing. Dink. Import. Easy peasy. And that gives us back our vector U8. We create a world with a global world ID, We don't need to add a spaceship. In fact, we're going to check for it later. So that's a spaceship we expect to see. So let's jump across to space, and in here I've got a little piece of code that creates a list of all the spaceships and formats them into a list. Remember, I kind of mentioned that really quickly before. So that there is going to be our test. So we got this function called space serialize. Yeah, well, we're going to create a function called space deserialize. This testing's got the ships in it. Space deserialize world. It's going to require our buffer input bytes. I want to give it a reference to the buffer. World ID is kind of irrelevant. Space build serialized. Okay, so if I go into space right now and into build, and we'll just scroll down a bit, we have a serialize function here. We need another function here called deserialize. We've got space serialization run now. So we're going to do kind of the opposite thing. Do we even use the same resource? I'm kind of picking yeah, why not? So we have a kind of a resource called shared serialized space with a space snapshot in it, which contains the data, and we're going to, in here we're going to have a reference to the data, so it's a reference to a vec of U8s. In fact, it really doesn't need to be a vec of U8s, just be a slice, and I just called it input bytes, which is this. So space snapshot dot, I want to recreate this vector from a slice. It's like a replace. I don't think vector has that. We might have to say grab this. So let mute serialized equal this, right? And then I'm going to clear the old space snapshot out dot clear, and then we're going to append from slice and pass an input bytes. I believe that exists in a vector. Let's ask our trusty reference. Where is our reference? Here's one. Vec. Dink. Extend from slice. Clones and appends all the things in there. So extend from slice. Extend from slice. Get rid of this so I can see you're talking. Wonderful. And then we need to run a system called space deserialization. Now you say, that doesn't exist, Tom. You're right, it doesn't exist yet. Well, that little clicking of my thing is making a lot of noise for you guys. Sorry about that. Okay. Let's make space deserialization. So space serialization looks a lot like space deserialization, not surprisingly. So let's copy this entire system and get cracking. Space deserialization, and we're going to implement system for space deserialization, and it's going to read from serialized space. It's going to write to pause, write to biped, write to spaceships, and still write to network entities. In run, we have to change this so it takes a mutable version of these things. No longer takes a mutable serialized, it takes mutable positions, mutable bipeds, mutable ships, and mutable network entities. Serialized space, we're going to unpack that guy still. However, it's not a mutable one we're going to unpack anymore, it's just a regular one. We're not going to clear the space snapshot first. Okay. Do we initialize a reader? How do we track our position through this thing? We probably can just use a reader. So we'll just say reader is a read. I think that's what we can do. Probably a reference to one, or is a read equals, and we'll say it comes from space snapshot. Yeah? Nah? Yeah? Can we do this? Does that work? Neat. Okay. So we're going to jump back across to our documentation that I never consult because I know all the things off by heart. So if you're ever in a coding interview and someone asks you something off by heart in the library, you just go, yeah, I just look at the documentation. That's what a real program would do, right? Let's have a look and see if it implements read. So there's write at the bottom here, but I want to see it implements one called read, QRS. I don't see a read here. We'll just search for read. Which is an IO. Here's a buffer that's just a slice. Here we create a new vector, that's great. If.read to end. Yes, this is reading into the vector. So it says here, a reference to U8 implements read. So everything's already a reader. My one question now is, does it advance some sort of read pointer as it goes? Yeah. Well, we can just try and see what sort of exciting things happen if we just treat it as a reader. In my reference, I think I already do reading. So in serialized ship, and I think I've got another one called DE ship, and in deserialized ship, I decode a block here, for instance, decode a component, read things from a reader. I get something called a cursor. Okay, that sounds promising. What's a cursor? A cursor wraps an in-memory buffer and provides it with a seek implementation. Cursors are used with in-memory buffers. This sounds exactly like what I want. Thanks, past self. We create a new cursor like this. Wonderful. So in the deserialization, they get hold of a buffer. Let buffer equal new cursor like so. Import. And the cursor is going to be the space snapshot again. So we're creating it from space snapshot. And we're just going to methodically work our way through this guy. So, the process we need is we need to try and figure out if there is already a net entity with the correct ID that exists in the world. If there isn't one, we're going to need to add a new entity, probably. Which might require a linear search, or it might require something smarter. Okay, so let's just follow the test-driven development principle. We're not going to allow the if we run this test twice, it's going to create extra spaceships. So if we run deserialize multiple times, it's just going to keep on making spaceships. And it's not going to be the correct answer, but it's going to be enough to prove the concept. And then down the track, we can deduplicate the spaceships. So how do we pop these guys out of this thing? Just going to bring back my little list of people that are watching so I can see and stare in terror into the abyss. 14 people are watching at the moment. Excellent. Thank you for watching. You should join my Discord. If you Google or search via DuckDuckGo for the Recall Singularity, you will find everything out about this, about me, about this channel, about the spaceship game I'm making, about the pretty crashing spaceships that we're synchronizing, anything you might want to know. So please do that, and join us online at like Discord and so on. Read articles. I'd love to see you on the Discord channel that you will find if you read any articles, or look in the chat window that's somewhere on Twitch. I'm not even sure how you get to it from where you are, but I'm sure you can figure it out if you try hard enough. Okay, run. In here, we need to deserialize these guys. So let's just very quickly get them. So to get a position, so let mask equal deserialize from, needs a reader, so we can use the buffer, which is a cursor. Deserialize from mask is going to be of type exists flags, like so. So we get that from the buffer, like this. Do I need to, when I call deserialize from, I pass in a reader and it returns a result that might be another, that will be another reader. Okay, so I can just say deserialize from reader returns a result. I'm just thinking that the reader, does the reader get cloned? Why do we not how do I do this in the other one? Reader as a mutable pointer to a cursor. Reader.read U8. Where do we do more reading? Decode component. Reader. It's just reading a single U8 here. That's not exactly what I wanted to see. I'm just trying to find an example of using SerDes deserialization. Okay, deserialize from. Okay, so we have a mutable cursor and we're dereferencing and passing. So even though it says here it's a reader and it's of type R, that's what I had to I spent so much time trying to figure this out. this looks like it's not a reference type, but it is actually a reference type. It expects you to pass in a reference to the reader, not the reader itself. So we can just, is it a buff? We're going to call this reader. So I'll just say reader here. Reader. We're going to deserialize from. We're going to pass in a mutable reference to the reader. And it's mutable because as we read the data, we in advancing a pointer saying like how far through the data we are. So the first thing we get is the exists flags. The next thing that we serialized, so if you look up here, the next thing we serialized is this thing called a net entry. So let net entry, which is a network entity, equal, again, deserialize from this. Now in each case we're going to have to unwrap, I believe. So this is, we're kind of assuming that it's going to be okay. Probably need some error checking. We're going to panic if we get a malformed packet. That's probably bad. Again, I'm just following a very quick and Yagni approach. This needs more work. There's probably a lot of searching for the word unwrap in my code base. It needs to be fixed. One thing about Rust is that that's all nice and obvious from a search. The next thing we want to unwrap, again, we consult up here. I might just hide this. We'll split this vertically. Right, so we've got two windows, and I'll scroll down. This is in the same file, and so this run is the okay, I'm showing both the same thing. This one is the serialized one. This is when we made the data, and on the left here is when we're unpacking the data, and I'm constantly going to look across to here to see what to do next. So the next thing we serialized was this position. So we got all these variables. This can be a bit of a nuisance to type up, but I guess that's just how it is. Okay, so the next thing we want to grab is this very complicated tuple that is basically a lot of floats. So let pos tuple is equal to a f32. Yeah, we're going to do this. f32 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 f32. We're going to deserialize that from the reader. That's the position, which is that data there. And I'm not interpreting it here. And then we're going to let the biped. So if mask and the flag biped exists, then we're going to grab, so we're going to say let biped opt equal if mask and biped exists sum. Yeah, and then we're going to deserialize from it. Unwrap. Blap. And so this is an option containing a biped. Else, none. So that's how you get your biped. And then the next one is, and so Rust is smart enough to figure out that you've got an option that has a biped in it. So when you go in here, it's returning something. The something must be a biped, because it can figure that out. It knows what to pass and to serialize from to tell it the kind of thing it's trying to unpack. It's all very cool. Okay, over here, option spaceship. If the mask flag spaceship exists, we need to deserialize from the reader a spaceship, which is also optional. Optional, else, none. Yeah? Okay. And we need to do that for every entity in the reader. So it's kind of a loop in here. So it's we have the reader, while we need to find out how to figure out how much is left in the reader. Probably reader.len, right? or left, or remaining, or it's just something called stream len, and there's something called stream position. Those two things together will actually tell us where we are, but I'm just wondering if there's something better than trying to call one and then the other. I think once again I need to grab my docs. I probably need to pull off my stream summary, this one here, it shows me you guys, pull that off and have a look at this. So cursor, I need to figure out position. What is the current position? You can set the position. What I want to know is how close to the end I am. Okay, so read doesn't tell us how much bytes is left, which isn't surprising. Right, seek probably does. Stream len, stream position. Okay, so those are convenience functions. They're not actually standard. Implements buffered read. Debug client default. Okay, so the one we want is called position, and we already know how big the buffer is. So let's use that to figure ourselves out. So let bytes byte num equal this one space snapshot.len. That's how many bytes there were. It's a usize. Well, reader dot position is less than, so reader dot position, so use 64 from reader dot position is less than the byte num. Either I put the u64 from around the wrong argument. It's the byte num that needs to be u64. We might just put that up here actually. While that's true, we'll keep on trying to extract spaceships. So go down to here, doof, trying to extract a spaceship, ta-da, and while that's the case, so all that's serialized into stuff that's for the wrong class, and let's just quickly dump this out, dbj, and we're going to specify all the things, mask, net entry, pos tuple, biped opt, spaceship opt, like so. And then we need to put another bracket because we're trying to debug an entire tuple, not a bunch of arguments into debug. And okay, and I've got a couple of problems with my masking here. I need to say is not equal to 0 at the end to turn them into booleans. And it pointed out there's not spaceship exists, but ship exists. Cannot find space in this scope. Where did I put space? Okay, so it's just saying that in order to call this, I need to have a whole world. Yes, so rather than the word space here, I need to use the word world. Okay, space deserialization is not imported. So, you know, if you hadn't figured out already, we're going to only call the serialized class on the server, and we're only going to call the deserialized class on the client. We're not going to run both classes on the same world generally, but we could as a nice little loopback test. We can't turn a U size directly into a U64 with from, which is interesting. I guess they're not limiting themselves, so we're just going to say as U64. Okay, so that's a much stronger kind of, can punch it in the head until it's the right type. It's never going to be anywhere near the size of a U64 or a U16, a U size, so it should always work. Expected struct found tuple doesn't return. In fact, this deserialized doesn't return any data. Sorry, that was misdefined function. So I expect to see a failing test with some cool data when this works, by the way, if it works correctly. Cannot borrow data in a dereference. Okay, so I just need to say fetch mute. Yeah. I don't think I need to say that this is actually a mutable serialized, because it's, oh, I don't know. It's just complaining that this function here, I said everything was mutable, but I don't actually change it yet, because that code is to do. Test framework quit unexpectedly. That's interesting. Oh, I see. The reason why is because I'm specifying a specific test, and that specific test has gone missing. Run. I need to run all my tests again. Here we go. Thank you for watching, by the way. Running my unit test. Ship creation. That's not the test I'm interested in. Spaceship. Space serialization tests. Deserialize. Oh, interesting. Tried to fetch data, but it was already borrowed mutably. Where are we trying to fetch it from? Inside space deserialization. Okay. So it looks like our list of things that we're trying to borrow here has got a duplicate in it. Serialized space, pos, oh, I see. So before I can do that, I need to drop my connection. See here, I'm actually got a reference to serialized. I need to put this in a block. So before we call space deserialization, we've released a resource like this. So the lifetime of this serialized variable dies here before this is called. You'll find the same things are important for mutexes and stuff you work with as well. Any kind of handle. I'm going to get rid of the succeeding tests and look at everything. And this looks like the kind of output I wanted to see. Right? It's a failing test because I haven't actually put anything in the world yet, and it's fine because I haven't written the code to do it. But what we have got is where our debug call is working correctly. So we have looked into the data, and we have 2, which is our mask. Our network ID entity has ID 1. Here are the variables that we've got for our position. So you'll recall that I put it at 1, 2, right? So that's 1 on X and 2 on Z. And then here is a 1, which I guess is a identity rotation, would be my guess. When you roll down here and have a look at the spaceship, its location is 1, 2, its ship box is 1, 2, 3, 4, its child world is 1. So that is a textbook success. And you'll notice also there's a none here and notice there's no biped. So that decode has worked okay. We just haven't made anything in the world yet. So down here, instead of debug, I can now invoke a world builder of some kind. I can, go something. However, it's currently 10 minutes till midnight, and I think that as far as success goes, I'm pretty happy with that. So I'm going to commit my work, and I'm going to, after I've done that, I'm going to call it a night. As for you, the 19 of you currently watching, and thank you for watching, I'd like to direct you to join my Discord channel. If you've enjoyed reading about me using specs and Godot and so on, come along and join us in Discord in the Godot Rust channel or similar. Here's an invite link just for you, and I'd love to see you. And if not, if you're about to go off and join someone else's stream and have fun just watching and chilling, I hope you have a really nice time. It's been a pleasure to see you. I advertise on Discord, Twitter, watch people code. Hopefully you came for somewhere good, and I'd love to see more of you. Or Google for Recall Singularity if you want to see more. Thank you so much. I'll catch you again soon. Probably at about the same time, 9 PM New Zealand Daylight Time. Expect to do it on Thursday, 2 days from now. So go back in time 2 hours 53 minutes, then go forward 2 days, so go forward in time 46 hours, and you should find my next stream. Thank you very much. Oh, hit follow buttons, that's another way of doing it. Thank you very much. Good night. Oh, I shall push these buttons here. Meow.